This isn't another false alarm. This is the single most promising candidate yet, because astronomers digging through dusty infrared archives spanning 23 years just announced they might have actually seen it move. So what exactly did they find, and why is this different? We all know the basic story. Back in 2016, researchers noticed something weird. Way out in the Kuiper Belt, beyond Neptune, a bunch of icy little worlds weren't orbiting randomly. Their paths were strangely aligned, clustered together, almost like they were being herded by the gravity of something big and unseen. That unseen something? Planet 9. The prediction was a planet maybe 5 to 15 times the mass of Earth, orbiting hundreds of times farther from the sun than we are. A true giant hiding in the dark. Finding it, though, that's the hard part. At that distance, sunlight is incredibly weak. A planet out there would reflect almost nothing, making it nearly invisible to normal telescopes looking for visible light. Think about it. 10 to 20 times farther out than Pluto. It's cosmic darkness. But here's the trick. A planet that big, even if it's cold, still holds leftover heat from its formation. It glows faintly, not in visible light, but in infrared. Heat radiation. That's why scientists turn to infrared sky surveys. Two key missions are important here. IRAS, the infrared astronomical satellite from 1983, and the Japanese AKARI satellite, which scanned the sky around 2006 and 2007. Both surveyed the entire sky in the kind of far infrared wavelengths where a cold, distant planet might shine. But even then, it's tough. The signal would be incredibly faint, right at the edge of detection, and the infrared sky is messy, full of faint, wispy clouds of interstellar dust called galactic cirrus, which also glow in infrared and can easily fool you into thinking you found something. In fact, earlier attempts to find Planet 9 this way ended in disappointment. A study in 2022 found hundreds of potential candidates, but they all turned out to be these annoying dust clouds. Hopes were lost in the cosmic fog. So what changed? How did this new team succeed where others failed? They used time, a lot of time, 23 years to be precise, between the IRAS survey and the AKARI survey. Why does that matter? Because Planet 9, if it exists, orbits incredibly slowly. Its year might be 10,000, maybe even 20,000 Earth years long. From our perspective, it barely crawls across the sky, maybe a few arc minutes per year. That's tiny. Over a few months, or even a couple of years, it would look stationary against the background stars. But over 23 years, it should have noticeably shifted its position. This team brilliantly compared the 1983 IRAS map with the 2006 AKARI map, specifically looking for a faint infrared source that moved during that time. They cleverly used a special AKARI list of unconfirmed sources, things seen briefly but not later, helping filter out stationary background noise like distant galaxies or those pesky dust clouds. They calculated where Planet 9 should be and how bright it might appear in infrared, assuming it was somewhere between 500 and 700 astronomical units away. They started with 13 potential pairs of detections, one spot seen by IRAS in '83 and another spot seen by AKARI in 2006, separated by just the right amount of sky to match Planet 9's predicted slow crawl. After carefully checking the images, they ruled out 12 candidates. Many were indeed embedded in faint dust clouds or had other issues. But one pair stood out, one single candidate. In the IRAS data from 1983, there's a faint blip at a specific location. Fast forward 23 years to the AKARI data from 2006. That original blip is gone, but about 0.79 degrees away, roughly 47 arc minutes, there's a new faint blip visible in the AKARI images. Critically, IRAS didn't see the AKARI source back in '83, and AKARI didn't see the IRAS source in 2006. It's exactly what you'd expect. A single object moving slowly across the sky over 2 decades. The amount it moved perfectly matches the expected motion for a planet 500 to 700 times farther from the sun than Earth. They did more checks. AKARI actually spotted its source twice in one day, but hadn't seen it when scanning the same area 6 months earlier. That points to a real moving object, not just a glitch or a permanent background feature. And crucially, they report no signs of those infrared cirrus clouds at either position. This doesn't look like dust. It looks like movement. Why is this such a big deal? Because it's the first time anyone has found a specific moving infrared source that behaves like Planet 9 should. We've had the gravitational hints, the orbital clustering, the theories, but never a candidate object caught in the act of moving. This shifts the entire conversation. It's no longer just, does Planet 9 exist? It's now, we might have actually found it. How do we prove it? If this is confirmed, wow, it would be the first new planet added to our solar system in nearly 180 years, since Neptune was discovered back in 1846 based on similar gravitational predictions. It would finally explain why those distant Kuiper Belt objects are acting so weirdly. People have been searching for a Planet X for over a century. That search led to Pluto in 1930. Okay, deep breaths. This is huge, but it's not confirmed yet. Right now, we only have 2 points in time, 1983 and 2006. That's not enough to calculate a full orbit or be absolutely certain it's the same object. The researchers are calling for follow-up observations. We need to point our modern, powerful telescopes at the patch of sky where this object should be right now. By 2025, it should have moved another half degree or so from its 2006 position. Telescopes like the Dark Energy Camera, or DCAM, could potentially spot it. By taking images a few nights apart, they could catch it moving against the background stars. If they find it, and if its position matches the predicted path based on the IRAS and AKARI sightings, then we could start fitting an orbit. That would be the smoking gun. That would clinch the discovery. What if it is Planet 9? What would it be like? The infrared data suggests it's likely 5 to 15 times the mass of Earth. Probably a mini Neptune or a super-Earth, an ice giant with a thick atmosphere of hydrogen and helium. Maybe like a smaller version of Uranus. Its temperature is estimated around 40 or 50 Kelvin. That's incredibly cold, about minus 220 degrees Celsius, but still warm enough to radiate that faint infrared glow from its formation heat. In fact, it probably emits 1,000 times more energy as heat than it receives from the distant sun. If we can get more data, maybe measure its color or spectrum, we could figure out what it's made of. Does it have methane like Uranus and Neptune? Could it even have moons? And its orbit? If it's 500 to 700 AU away, its year could be 10 or 15,000 Earth years long. Think about that. The last time it was in this part of its orbit, humans were possibly just developing agriculture. It's mind-boggling. Where did it come from? Was it formed with the other giants and then flung outwards in the chaotic early solar system? Or was it a rogue planet, wandering interstellar space, that got captured by our sun's gravity? Its orbit, the tilt, the shape, will hold clues to its origin story. Interestingly, the candidate's location in the sky, roughly towards the constellation Cetus or Orion, seems to align with some of the original predictions by Badigian and Brown. Confirming this candidate would also help clear up other mysteries. Does its gravity perfectly explain the clustered KBO orbits? Could it explain other weird objects with highly tilted or even backward orbits? Does it fling comets towards us from the Oort cloud? Finding the planet is just step one. Understanding its role in the solar system opens up a whole new field of study, and finding an actual infrared object pretty much rules out those more exotic ideas, like the gravitational pull being caused by a tiny primordial black hole. A black hole wouldn't glow in infrared like this. This discovery firmly points towards a planet, an extraordinary planet, but a planet nonetheless. The next few years are going to be crucial. Even if immediate follow-ups are tricky, the Vera C. Rubin Observatory is coming online soon. It will repeatedly scan the entire southern sky over the next decade with incredible sensitivity. Planet 9 might be right at the edge of its detection limit in visible light, perhaps magnitude 22, which is extremely faint. But Rubin's power lies in its repeated scans, making it excellent at finding faint things that move. Many astronomers believe Rubin is our best shot to either find Planet 9 for sure or definitively rule it out. The clock is ticking. This whole saga is like a cosmic detective story unfolding in real time. We had the clues, the gravitational breadcrumbs. We searched the darkness. We faced dead ends and false leads. And now, finally, a tangible suspect has emerged from the shadows, spotted moving across decades-old infrared film. So the big question hangs in the air. Is this it? Have we finally found Planet 9? We're standing on the edge of potentially rewriting our place in the cosmos, adding a new massive world to the roster. Confirmation is key, and the hunt is now more focused than ever. What happens next could change everything we thought we knew about our solar system's borders. Keep watching Deep Research. We'll bring you the updates as soon as they break.